In this tutorial, we're going to be baking decal images into the textures of a 3D object. We're going to be using a tool called XNormal, and then we're going to have to make some corrections to the images that we create in XNormal in Unity 3D with material tools. I'll show you the objects that we're using. In the last tutorial, we exported this wall mesh and this plane mesh into FBX 3D objects. Those FBX files are part of the input file that I have for download on the web page for this tutorial. I'll download that and show it to you real quick. Okay, so these are what the two FBX files look like. This background was a wall, position decals was the plane. So in this tutorial, what we'll be doing is we'll be baking decals. I also included these for decal images, a mask, a height, a normal map, and an ambient occlusion map. And we're going to be using the plane to kind of position those textures to bake into the background, the wall. After we do that, there'll be a couple other steps. From those, we'll get something like these images, where I'll show you those real quick. Ambient occlusion, height, the mask, the normal map, and there's this last one, the baked UV map, which we're going to be making in the same way, but we're going to be using a different texture that I included in our inputs, the UV map. And as a material, it'll look something like this. It'll show it as textures, and if you look at the mask, it'll look like this. But we'll have to do two things after this to correct these images. We'll have to fill in the empty space here, all this black space right here that has no data, and we'll have to correct the normal maps. So I'll kind of show you what that looks like. Let's compare it to it without the mask on it. This other one doesn't have a mask. See, the white areas have actual data. This is once we use a buffer tool from material tools to fill in just neutral data all around this area where we don't have the decal. And I'll show that with the mask, so it's a little bit easier to see that decal. And then the last step's going to be hard to make out. It's fixing the normal colors using a tool called Rotate Normal Colors. And it looks pretty similar to the buffered texture. The difference is really subtle. It's just in how the decal's going to reflect light. I will try to give you a bit of an idea how that works. It might be a little easier to see with the mask on. So this is how it's supposed to reflect. And when I move it diagonal, you can see the light move diagonal pretty well with it. It looks a little different here. Where you can really see it is in the normal map. Here's a normal map for before the rotation, and here's a normal map for after. So a very subtle difference. It's just this coloring. It's changed from the greenish color. I just wanted to give you a general idea of what we're actually doing in this tutorial. All right, let's get baking. So what we need is an XNormal window. I have links to that so you can download it, and we need our input files. So XNormal is a tool intended to take a high definition mesh with a lot of detail, like actual geometry detail, not decals, and a lower definition version with less detail, and bake the high detail into images like our decals that fit on top of the low definition map. But in this case, we're kind of using a little bit of a hack where we use just a plane with a decal on it as our high definition mesh, and our low definition mesh is our actual geometry. We'll start with just giving a general overview of how the interface works and where everything is. You can see in XNormal there's these buttons on the right. Those are like tabs for different kinds of input. We're going to use the high definition meshes one, the low definition meshes tab, and the baking options tab. We don't need any of these other ones for now. Tools has some good things that you might want to explore on your own, but we're not going to use them in this tutorial. Okay, so the normal way you'd use XNormal, you'd go into this baking options tab and you'd select the maps that you want to create. You'd create a normal map, a height map, ambient occlusion map, and then if you were doing a mask like we have on our decal, you'd do a bake base texture. But when we're baking a decal into a mesh, we don't use all of these. We don't use ambient occlusion, height, and normal. We just use bake base texture, and we run it multiple times. So it'll just be creating one image at a time. And there's some other settings that we can set right now that'll be common to each one of these images that we create with a separate run. The output file will change, so we're not going to look at that yet. We'll come back to that. The size should be the same for all these images that you create. We're just going to leave it at 2048. That's good enough for this example. Edge padding needs to be set to 0. Bucket size, you can set to what you want, but 32 is fine. Anti-aliasing, you have a few options. I like to set it at the highest, 4x. I think it gives you a more detailed image. The render options, I usually use a default so that it'll use your CPU to do the calculations. You can change it to CUDA render if you have certain types of video cards, and it might work faster for you. I haven't used OpenRL map render. And then I just check both these boxes. Closest hit if ray fails, and discard backface hits. I don't think with this example it would matter either way if you discarded the backface hits. There's some occasions, though, where you're going from a high definition to a low definition where the two meshes kind of cross. So the low definition section, we should be able to set all the stuff in this window once, and it'll be consistently the same for all the runs that we're doing. First, we need to select the mesh that we're going to use. You right-click to get this drop-down, and then press Add Mesh. And then for the low definition, we want the background. Our plane's going to be our high definition. And then you'll want to change the maximum frontal ray distance and maximum rear distance. And that's just based on how far away the low definition mesh and the high definition mesh are going to be at the maximum points that you want to consider. So we should be okay with 0.1. You want these values to be large enough that they actually find the high definition mesh, but you don't want them to be too large. So what XNormal is going to do is it's going to take your low definition mesh and it's going to go through each location on that low definition mesh where it's going to place a pixel on the image that it's going to produce. And it's going to cast a ray out and look to see if it runs into anything. And if it runs into anything, it'll use it in the production of the textures. So with us just doing the bake base texture, all that it's going to do is it's going to reach out to that high definition mesh, find a point on that high definition mesh, check with the texture that's on that high definition mesh at the point that it hits, and then paint that point on our low definition mesh's texture. So if we have too high of a value for this, we might get places where there's an angle and the low definition mesh isn't supposed to map to anything on the high definition mesh, but it might reach out far enough and hit the side of the high definition mesh and give us a point that we weren't intending to have at that location on the low definition mesh. So that's all we need from the low definition mesh. We're done with that for the rest of the tutorial. Now let's look at the high definition mesh. So all the calculations on the high definition mesh are going to use the same mesh, the plane, position decals. But we're going to have different textures on it. So now we can go back and set the inputs for our first calculation. And we can start with this high definition mesh. These are going to change each time we calculate. Now let's right click on this again, base texture to bake, and I'm in my downloads folder, the folder for our inputs. It's 2 folders, and then the decal. And we're going to want to go through and do each one of these. So let's start with the mask. So now let's go to baked options, and all we need to change before we run it is the output file. For this tutorial, I'm going to put it in our downloads files so we have everything together. But normally you wouldn't do this. Normally you'd have a place on your computer where you keep this stuff. If you create a folder when you're doing this and then put your stuff in there rather than just naming it after a folder that you haven't created yet, it'll save you an error. Okay. So I'm going to name them all baked decal, then dash, then the texture type. So this one's mask. And you just hit the generate button. And there we go. There's our mask. So we'll do the normal map now. And we just need to change the base texture. Okay. And now the height. And the ambient occlusion. Last, we're going to do one called Baked UV. We're going to use this one for rotating the normal colors, which is the last step of this tutorial. And we want to use this UV map, which is just linear from left to right, black to red, and from bottom to top, black to green. And so they combine to make yellow in the upper right-hand corner. Okay, so with those 5 textures, we're done with the actual baking, but we still need to make some corrections to these. None of the textures have real data in the pixels around the decal, just transparent pixels. The normal map will require an additional correction. We can close XNormal. And then we're going to be using Unity. We're going to need to add our assets. And for now, we just need those outputs. We're actually not going to bring those same 2 meshes into Unity. We're going to use the original OBJ that we made the background from. But we'll do that in the next tutorial. The next thing we need to do is to download material tools. You can bring up the asset store by going to Window, Asset Store, search online, and then it'll bring it up in a browser. And go ahead and search for material tools. The time I'm making this, I haven't uploaded it yet, so it won't show up. But you have to purchase it and then download it. And when you download it, it should show up in the package manager. And let's download one of these other ones just to show you how to do it. I'll download this 24 PBR materials for Unity 5. Check the ones that you want to download and press download. Okay, we're going to import this. And you should be able to do that with material tools. It'll just be in the asset folder. I'll pause the video and stick it in the assets folder. Do that since that won't actually help you, me showing you that. Now that we have material tools installed, we have a tab at the top of the window named Tools. You can click on that, hover over Material Tools, and then Mask and Overlays, the main tool, but there's some small ones that are useful, and we're going to be using 2 from the supplemental tools in this tutorial. First, Buffer, and then later we're going to do Rotate Normal Colors. So click Buffer. Let's go ahead and bring up our output. The textures that we need to use a buffer tool on are the ambient occlusion, the height, and the normal map. So we can add those all at once. We're just using the buffer textures tool to fill in the background that was currently empty with the appropriate color for each of these textures that we're using. So leaving it set to auto should work for all of these. So what buffer textures does is it goes through and it finds areas where the pixels aren't clear. The alpha channel's not below a certain value. And then it goes along the edges of those regions and crops off a couple pixels based on what you set for crop pixels. And after that, it buffers outward, copying the pixels at the edges out into the clear pixels next to them. And it'll do as many as you have in the value of buffer pixels, and then it goes on to the next ones. And then it comes back and repeats the number of times you have set to iterations. And then once you have that all done, you've gone through all the buffers for all the iterations. Then you fill in whatever cells are still transparent with the fill color. So what we want is we want to crop a couple pixels off, then skip the buffering, and then fill in pixels. So you can do that by either setting buffer pixels to 0 or iterations to 0 or both. Lower color limit we can leave as 1, and we'll crop 2 pixels off. It's a good idea to do that just because sometimes when you bake a texture, you get some averaging of colors at the edge. And when you average real data with null data, those clear colors that we're getting in these maps don't represent anything. They just, well, I guess they represent that you don't have data. But if you average them, you get garbage. So it's a good idea to crop a little bit of it off. And we can leave auto select number of threads on, and buffer into clear should be fine. We don't need to buffer black as well. And we can hit calculate. Now here we have a new folder called Material Tools Output, which is where all the folders that have output for material tools are located. Buffer, and they tend to put them in these resources folders. We have our ambient occlusion, our height, and our normal map. And now we can rotate the normal colors. And I'll do that by selecting Material Tools, Supplemental Tools, and Rotate Normal Colors. Go ahead and use this texture you just created for the normal map. And we're going to have to select Use Textures. And this, in the output folder, is what we created the baked UV for, is to rotate the normal colors. We can change a couple of the advanced options to help us here. We'll want to round rotation degrees to 5, and everything else we can leave the same. Often with round rotation degrees, it's a good idea to set it to a number such as 5, 45, or 90 degrees. This corrects for the imperfections in the calculation, but it requires some knowledge for how the plane for the decal was positioned. If it was rotated some odd number of degrees, like say 33. Then rounding the rotation to the nearest 5 degrees would give you an error. But since I know that it was aligned along an axis and was rotated 135 degrees, rounding to the nearest 5 degrees should correct for any minor error. We don't want to print the rotations. That changes your result to kind of show the regions as different colors. Sometimes you want to do it a second time and see what it looks like with that. And compensating for anisotropy would be if your plane was not square, it was a rectangle. You'd want to use that. And then we can look in the Rotate Normal Colors folder. And we have a new result. And here it is. Like when I showed you at the beginning, it's kind of reddish color. And the old one was green. I'll see you in the next tutorial where we'll use the textures that we've made here and mask and overlay them into other textures.